Yes, I would just like to say good morning to all, and on behalf of Sparos, thank you for joining us. This session is going to be all about exploring how digital nutrition can help to optimize salmon feeding and nutrition. And a big thank to Stephanie, to Trevor and Ian Carr for organizing the panel, and to Don and David for accepting to be here and share the insights. And also, we look forward for this discussion and also for your questions at the end of the session in the Q&A. And we would like to begin right now to recover the time, and we'll start with a quick round of introductions. I am Nobre, and my role at Sparos is to lead our digital nutritional tools and services.
Yeah. So I'm Stephanie Arnott. I work with Veramaris as Technical Business Development Manager. And at Veramaris, we produce a highly potent algal oil that's sustainable, certified and renewable source of EPA and DHA that the aquaculture industry can use.
Hi, I'm David Morrice. So I'm working for a feed company, EOS Cargill. I'm working in the commercial business development area in our North Sea feed business.
I'm Don MacLeod. I'm Regional Seaward Manager for MOWI, covering the Western Isles and Skye.
Hi, and I'm Trevor Telfer. I'm from the Institute of Aquaculture at Stirling, and I'm an academic, and I work on aquaculture environment interactions. So over to me. So thanks very much, and thank you, Keith, because you couldn't have given a better introduction, because you've set the scene. We're hopefully going to talk today about tools and methods to use some of the technologies and some of the data that you've actually talked about. So absolutely fantastic. Because we know that the evolution of digital technologies to improve what we're calling precision farming, that's what it's all about, has increased over the last decade. And use of automated feeding technology models and cage sensors have revolutionized salmon farming particularly. We've now got real-time monitoring through sensors, camera technologies connected to the internet, connected to the information of things, the Internet of Things, IoT, to give instant data. I go to a lot of fish farm sites and I see NASA control headquarters with screens and screens and screens full of data, and I'm thinking, my goodness, I wish I could get hold of some of that data. So please, can you give it to me? And of course, that allows us to constantly monitor the environment, fish health, feeding responses, and that lets us make data-driven decisions, exactly what you've been talking about this morning. And that improves not only health, welfare, it also improves feeding schedules, it also improves health management of fish. So predictive models are being used more and more and more for environment, for feed management, for forecasting, feeding patterns, and digital tools also allow the reduction of waste through better farm management and more efficient use of energy, which is a big thing at the moment. So we're talking about carbon footprints and things like that. So what we want to do today is discuss the impact of these digital tools, particularly in the salmon industry, and their future use, and particularly we'll explore the latest trends and needs in the digital space, focusing on optimization of nutrition and feeding. So without better to do, I'm going to open the questioning. So Don, one for you. What recent feeding advancements adopted by MOWI have had most impact in your work and the way forward?
I think we've got, I've got a wee slide here. So, I started my career back in the late 90s. Back then, we were using, I'll start with pen sizing and feeding, that's kind of the first point. We were using 15 metre square pens back at that point, about 1,800 cube of volume. And now, in recent years, we've seen 160 metre pens, 200 metre pens coming into the Scottish industry. The 200 metre pens we're about to install, starting next year, will be about a 60,000 cubic volume So a huge step up from where we've been 20 years ago. Now, with pen sizing, obviously the scale, cost dilution comes along with that, but the difficulty in feeding that size of pen. Back with the 15-metre pens, we were hand feeding, no such thing as cameras back then. It was all surface reaction. It wasn't until we started upgrading to the plastic pens, 70, 90, 100-metre pens, that we started using cameras. The cameras back then, really grainy, analogue. So it was the early stages then. But also with feeding, the feed barges that we use these days as well. We started adopting feed barges probably in the early 2000s. Smaller capacity barges, 2 to 4 line capacity. Back then, with a lot of smaller pen sizing, you were feeding 5, 6, 7 pens per feed line. So it was a very inefficient way of feeding your fish. These days now, we have 500, 600 ton capacities up to 12 feed lines per barge. So the scale there and the ability to have feed 1 pen per feed line, it's a huge step forward. Next would be camera quality and their abilities. I mentioned about the analog cameras in the early 2000s. Obviously now with like what Keith was talking about there, the high definition cameras, we've got the ability to lice count, biomass estimating, fish behaviour, all driven by AI. So the advancement in the last few years, like Keith's saying, the pace in the last few years has just been unbelievable. So it's quite an exciting thought where this can lead to in the next few years. And then remote operation centres. We created an ROC. I think most, if not all, fish farming companies in Scotland have some form of ROC. We have one in Fort William, currently feeds about 15 farms. We've recently just closed off a couple of the initial farms that were introduced to that ROC. Some of you might have seen the result we achieved in Gorston, economic FCR of 1.002, which is certainly Scotland's and MOWI globally is one of the best results that we've ever seen. Also, just in the last few days, we've closed off a farm in the Argyll area, Crovehaven, historically a really difficult area to grow fish in. Economic FCRs generally in the 1.1, 1.15 region. Now that was a later addition to the ROC, tail end of last year, but that's finished off on a 108. So we can already see, the advancing of ROCs and how focus on feeding and standardisation of our feeding practices can really drive results. So then, how can these advancements help us going forward? Higher level of data gathering and learning, just exactly what Keith was saying there previously. Gathering all this data through AI really is going to open doors to change how we look at farming and more put us on a proactive approach to farming more than reactive by trying to get really ahead of health issues and really optimising our feeding. Then updating of growth and planning models. Now, with this change that we've seen in this last year and the results that we're seeing, if we can replicate this across multiple farms, then our forecasting tools, our budgeting models and everything, it's all going to have to be updated because we can gain these increases in performance. If we can standardise that, then it's going to open up a whole new realm of financial results really at the end of the day. And then better standardisation of feeding practices. It's one thing that I've really noticed myself. I've spent a little bit of time in the ROC in Fort William. We are now rolling out another ROC up in Stornoway to cover the Western Isles and Skye. But the focus on feeding through the ROC with the aid of AI and the feedback from the cameras, great connectivity to the farms, we are seeing big strides there in our results. Offshore and submersible farms. I suppose when we've got this kind of standardisation across the business, it lends itself then to give us confidence in maybe going a little bit more offshore, knowing that we've got a very predictive way of farming, a proactive approach. So I think it will then allow us to push further offshore, bigger farms, better cost dilution overall, and again, improve results as a whole. And then finally, just controlled expansion. By standardizing, by trying to improve our results across the business, then by way of default, regulators then can look at us and be confident that we have control across our whole business. We can gain these 1002 FCRs as a standard going forward. It's that kind of standard of result is maybe exceptional, but I do really think in the 10 somethings is very achievable going forward. So yeah, controlled expansion. It's something that the whole industry will want to aim at, but controlled expansion, yeah, it has to be in a form that you have confidence in what you're doing, and I think AI can do that for us as well.
That's great. Thanks a lot, Don. Anna, what about? No, I've got to get the pronunciation right now. Sparos. Yes. Sparos. Thank you. Portuguese not very good. What about your experience through Sparos with the digital nutritional tools? What are the key outputs do you think these can bring to industry? Certainly in terms of the advancements that Don's been mentioning earlier. So what would Sparos' contribution be?
So we also had prepared a slide, and very, very briefly, digital nutrition. When we talk about digital nutrition, we mean solutions that apply scientific knowledge to be used by the industry to do exactly what, since the beginning, Kit have been mentioning, to do data analysis of the production, and also to be able to create feeding plans based on the fish feed requirements of each farm growth curve, and also to be able to test scenarios, test different strategies before field implementation with predictive models, and also, very importantly, to allow interaction with these more complex tools through simple user interfaces. So this is, let's say, the tool set of what is digital nutrition. And at Sparos, we had developed models that predict fish growth and key performance indicators based on feed, composition, and quantity, and also under the specific farming conditions. Of course, we have developed this also for the Atlantic salmon, and very importantly, to be robust, to be used by the industry, it was validated with real production data. Now, building on Don's point, on MOWI's direction, here are some examples of digital nutrition that can help and support the production. One is custom feeding plans and production plans created with models, nutrient-based models, that calculate the feed needs to eat these updated growth targets. Also, the feed performance analysis, specifically analyzing the feeding data to unveil insights from all this data that is being gathered. But very, very importantly, there is not going to be a solution that is going to give like miracle questions. It is really important that the objectives of the analysis are defined by the users, by the companies. It could be, for instance, based on real production data, to analyze, based on the historic data, what is the best fish range size for the pellet transition, analyzing the real production data. Or, for instance, looking into different DPD ratios and evaluate which turn into the best performance. Just a couple of examples. And further, if you enrich the data analysis with the deviations between real data and the predictive models, this also can give support to spot patterns and isolate the factors that contribute to best performance. Don already mentioned the key factor was the auto-C. But then after the auto-C is a standard, there will be certainly differences between farms, between pens, and this is the type of analysis that can help to spot it.
Brilliant. Thanks, Anna. Actually, back to Don. We're getting our money's worth out of you today. What do you think? These are clearly predictive tools that can estimate feed requirements, develop feed tables, and things like that, and actually utilise some of the things that you were talking about earlier. Do you think this sort of tool would be really useful to MOWI or the industry in general?
Yeah, I mean, absolutely. I think, again, just going back to what Keith was saying, I think we're coming into a new age, a new digital AI age now, and the speed of that in the last few years has been quite fast. So going back to the ROC point, if we can standardise across the board and we start seeing these consistent 1, 0 something biological economic FCRs, then every little marginal gain that we can have on each individual farm, each farm's different, each stock's different. So investigating all these little areas, I think, is going to be key to nailing down that FCR even further.
That's brilliant. Thanks very much. Over to Steph. Another practical example of a digital tool, of course, is Veramaris's omega-3 deposition model. Can you tell us a bit about that and why it was developed and how it can support industry?
Yeah, so people eat salmon for a reason. And a study a few years ago found that 2/3 of consumers buy salmon for the health benefits associated with EPA and DHA. Now, at the same time, you've got the NHS and other health bodies asking us to eat 2 portions of fish per week, one of which should be oily, like a salmon. And that kind of means that 1 portion of salmon should contain enough EPA and DHA to meet our weekly recommended level to support human health. And that is just not what we're seeing in the market at the minute, which is the challenge here. Oh. So you can at Veramaris, we developed the omega-3 deposition model, or O3D model, because we saw this gap in knowledge within the industry about really understanding how much EPA and DHA you need in the feed to be able to deliver a consistent level in the fillet. And that's the most important thing, is this consistency. Oh, I'm not even pressing buttons. And I've completely lost my space. So the gap in knowledge was kind of highlighted by a couple of different studies, but one you can see on the left here, where samples of salmon were taken from UK supermarkets, both Norwegian and Scottish salmon, and you can see the variation in EPA and DHA was massive. And only some of the Scottish samples actually met that weekly requirement for human health. So we saw this as an opportunity to develop a digital tool that would allow the industry to better understand the relationship between EPA and DHA in the feed and how that's deposited in the fillet. And at the same time, hoping to provide a tool that would allow farmers in particular, probably, to really create and capture this sort of extra value that might be getting left behind at the moment, because we know that that's why consumers buy it and that's what they're willing to pay for. So we partnered with Brett Glencross, who developed the model, and then we partnered with Sparos, who really brought it to life in the web app. And importantly for us, this was grounded in science, because the industry is so data-driven. And then, like Anna said, with her models, we validated it against real-life data, because it has to be commercially viable. There's no point in just using trial data for this. We had to use commercial data too. And then we also published 2 papers on this, basically detailing everything. You know, we're not trying to hide anything here. We want the industry to have access to the data, because we want you to trust it and trust that the model outputs are accurate. And it works in two ways. So you've either got the fillet model, where you can predict a level of EPA and DHA in the fillet if you know how much is in the feed, or you can use the feed model, where you can calculate how much you need in the feed to achieve a certain target in the fillet. So it works in two ways. And from Veramaris' point of view, you know, our algal oil is already really well documented and widely accepted within the industry globally, maybe less so in Scotland at the moment. So, you know, from our point of view, it's kind of, our interest lies in making sure and providing tools that make sure that the industry can use our oil and other EPA and DHA sources in the smartest way possible, in the most efficient way. So we know consumers buy salmon for the health benefits, and the O3D model is a step towards enabling the industry to really improve the consistency of their products, reduce this variation that we can see, and really deliver on the promises that we're making to consumers and the retailers. And I mean, essentially, at the end of the day, we're trying to secure or safeguard salmon's reputation as a healthy food.
Good, thanks. Thanks very much. So we all know that omega-3 fatty acids is incredibly important. And it's a big selling point for salmon. But from the feed producer's perspective, how would such digital tools, particularly the O3D deposition model, how would that support the industry in your terms?
Yeah, I think. Hello. Yeah, that's it. Better switch on. No, I think to back up what Steph said. I mean, we did an extensive studies, consumer studies, and it reaffirms what Steph was saying about around, you know, the halo around salmon is, you know, partly due to the health benefits, omega-3 being a real driver of that. Mm-hmm. But I think also you can get even more specific into the sort of consumer segmentation, and actually, you know, that targeting of consumers who actually, you know, are buying salmon for health. But I think on the practical terms of having a model, I think understanding the deposition to provide the accuracy. I mean, from a feed producer perspective, we don't want to be oversupplying if we don't need to. You know, this is a cost question. Omega-3 is a cost driver in the feed. So, you know, accuracy around, you know, oversupply, undersupply is really important. But of course, you want to be as accurate as possible to deliver the specification for further downstream. So I think tools like this are definitely invaluable in that context.
Brilliant. Still to you, actually. Of course, Cargill, a huge company, so you've clearly got a lot of experience using your own tools for particularly precision nutrition. So could you tell us a bit more about them, and particularly if you've come across any barriers to their use?
No, I think, you know, our journey, you know, within nutrition and using sort of digital tools, it really first started, I don't know, 20 years ago, I think, and we developed a model around. It was called the EGI. We forgot to actually put our company name in, so we missed a huge market opportunity. And that was all about, you know, predicting growth, much like what Anna was saying, predicting growth, predicting feeding, and then, you know, our customers, you know, really appreciate benchmarking, so understanding their performance historically, but also trying to look forward. And I think within that database now we've got, I think there's over 1 billion salmon. So, you know, the potential there is enormous. AI wasn't around when it was first developed, so, you know, there's probably still, you know, a lot of insights that we can even still take from that. Our approach now, yeah, as you said, Trevor, is more around being more precise and dynamic to meet the situational needs of the fish. I mean, that's critical, and we see a lot of value there. Yeah. And I think, you know, within the feed industry's made big gains, you know, over the years. But I think this is the kind of next step, just being, you know, optimizing and fine tuning, and I think moving from more static offerings, which maybe has been more the historical context, to being more precise, delivering the nutritional offerings that can meet the needs of the fish, which are growing ever more complex. And I think within that you've got you know, the environment that the fish is in, But you've also got external factors to think about, things like raw material prices. You've got things like tariffs and what that does. So, excuse me, regulation. So, you know, I think the nutrition also kind of feeds into that as well. And our approach really, I tried to put it in a slide there, is developing, you know, accurate predictive nutritional models. We start off in tank trials. We look at, you know, all the sort of variables around nutrition. I think we've made really great progress with you know, our latest work on that, around the sort of cost options there and performance, sort of cost performance equation. Then we overlay that with you know, what happens in the sea, geography, size, etc. And then what that has allowed us to do is, you know, the R&D is core that then feeds into these models, and then, you know, we're able to give customers options around, you know, the cost and performance that meets their strategies. And I think that in itself then just leads to a kind of more dynamic approach to actually what the customers will choose to feed the fish.
Thanks very much. We're going a bit for time, so a quick question to both Anna and Steph, actually. You both mentioned, Steph, you said the O3D model, and of course Sparos as the feednetics model. And you've said both of them quite rightly are underpinned by data, but also backed up by scientific information, scientific papers and things. Have you explored further collaboration with scientific partners or industry in developing these things further?
Yes, obviously we collaborated to build the model in the first place. And, you know, just to be clear, this is only version 1 of the model. It was only launched last year. So yes, the data in there is robust and backed by literature and science, and then validated against some projects in real life data. But we would love to collaborate with like the MOWIs and the Cargills of the world to use their real life data, because there's so much of it in these companies, to really build a sort of like a MOWI O3D model or a Cargill O3D model. You know, we can make it try and make it specific to those companies. And I think sometimes a challenge with larger companies, and we talked about it before, David, you know, around the bigger companies want to do it all themselves and keep it in-house and keep the science in-house, which is completely understandable. But when a model's been made and it's been backed by science, it's almost like you don't need to reinvent the wheel again. You know, work with the companies that are doing the R&D and making sure that the data's behind it. And we can work with you to make a specific model, you know, for each company. It's absolutely possible.
Brilliant, Anna.
And I totally agree with all you said, Stephanie. And there's this also, then from a technology perspective, to bring these scientific validated models, and like Stephanie mentioned, you don't need to reinvent the wheel. One possibility, having in account that big companies will have their own R&D departments, digital tools departments, is to allow the modeling engines to be accessed through application programming interfaces, so they can keep all the development they do. They just do a call for the model and got the results and embed that in their existing systems. One advantage, just to give 2 examples, could be Cargill, for instance, have very good model, very well known historically, the AGI for salmon, but probably we'll have a need for other species. In our hand, we had, so Feednetics is also published, as the Veramaris model is also published. We have developed for Mediterranean species, bream, bass, meager, also for the Nile tilapia. So it's there, it's available, and the modeling engine can be used for internal consumption. Also, Kit was mentioning the feeding analysis and the feeding requirements. Perhaps it might be useful to bring another point for your data analysis with the results of a biological model, giving the theoretical reference on a day what should be the consumption for this spend. So I think there's a lot of room for collaboration that can fit each company demands. Definitely.
Brilliant, thanks very much. So, final panel question. Don, you're at the sharp end. Okay, are you convinced? Is things you've heard today actually useful, do you think, in terms of nutrition optimization and something?
In a nutshell, yes. I think with MOWI's direction now, we're modernising our feeding practices and already seeing some early good results of that, obviously, as I've discussed. So I think with everything that's been discussed so far, the opportunities going forward with digital tools, I think is an exciting era, because it does feel like we're stepping into a new digital era within aquaculture. So it's going to be exciting times ahead.
Thanks.